Today we're going to be talking about magnetic field lines. And magnetic field lines become essential for understanding how a generator is going to work. A generator, by definition, is going to be something that takes mechanical energy or motion and converts it into electricity, which is going to be electron motion. And in order to understand how we can get from a magnet to electricity, we have to understand some basics about how a magnet is going to work and how that magnet maybe influences an electron. On the screen, there's a picture of a magnet, and you notice that there are going to be all of these little compasses. These compasses are going to show the magnetic field lines around the magnet, and you'll also notice that they go through the magnet as well. This magnet is also symbolic of what the Earth looks like, especially if you were going to flip it 90 degrees and rotate it. You have a polar region on the top of the Earth and a polar region on the bottom of the Earth. On the Earth, it's actually the South Pole on top and the North Pole on the bottom, but that's a different conversation for a different time. You'll notice, though, that as you move the compass around the magnet, the direction of the compass is going to change. This becomes really important. This means that even though there's a magnet present, the force and the direction surrounding that magnet are going to change depending upon the location of the magnet and depending upon what is feeling that force as you move around. Now, eventually, what ends up happening is instead of having a compass here, we end up having electrons, and those electrons are going to be in a coil of wire. Those electrons are going to experience a push type and pull type of relationship with the magnet. So previously we were moving a compass around. Now we have a loop of wire. And in that loop of wire, these blue dots represent electrons. The electrons are relatively speaking fluid within the metal, which is why metals are going to be conductive. The same way that water is fluid within a hose, it can go back and forth depending on the pressure that's being exerted on that water, these electrons can go back and forth as well, depending upon how much pressure is being placed on them. Right now, there's no pressure being placed on them. There's no force that is changing for those electrons. But if we move the magnet around, we notice that the magnetic field lines in certain spots have the ability to change. But the electrons don't really seem to be influenced yet. If the electrons become influenced even more, what will happen is these electrons will push through and they'll push through the light bulb and then they'll come back through the wire. And this is how all of our devices, whether it's a blender or a toaster or a cell phone charger, this is how all of your devices that get plugged in, and even those that are battery operated, this is how they're going to function. The electrons essentially flow through that device, but we need something to be able to force or cause that those electrons to be pushed through. So if we take this magnet and we push it through the loop of wire, we notice that that gives us the greatest impact or the greatest influence on how to push or pull these electrons. So as this magnet is going through, the magnet going through the coil of wires creates the magnet creates magnetic field lines. The moving magnet means that the magnetic field lines are moving or changing. Those changing magnetic field lines cause a push or a pull to happen on the electrons, and that push or pull is going to end up causing or creating electricity. So, in a different video, we talk about how a generator is going to work, and there's many different ways that we can get this magnet to move on a continuous basis. But the main source of electricity, regardless of what your source is, whether it's natural gas or hydroelectric, the main source of electricity ends up um, your source is going to somehow cause or create this magnet to constantly interact with a loop of wire, which means by constant interaction and changing magnetic field lines, we produce constant electron movement, which also produces constant electricity.